All right, today in geometry, we are looking at day 2 of Learning Target 1.2. We're going to deal with measuring angles. Okay, so first we want to start out with what is an angle. So an angle is formed by two rays with the same endpoint. Each ray is a side of the angle, and the common endpoint is the vertex of the angle. So in this picture, my vertex is point Q. This is my vertex. And then the sides are ray QR and ray QP are my sides. What is in between those two rays, that is the angle. So we want to talk about how do we name an angle. So there are different ways. We can name an angle with 3 letters. If you name an angle with 3 letters, the vertex must be in the middle. And then the order does not matter. Our symbol for an angle is just this symbol here. So I could call this angle RQP or angle PQR. Notice that my vertex Q is in the center. I can name it with just the vertex. So if I name it with just the vertex, I would call this angle Q. And sometimes they will have a number. So you notice that this one has a number. I can name it with a number. And so I would call this angle 2. So those are all the ways that we could name that angle. Yesterday we looked at the ruler postulate. So today we have the protractor postulate. So, goodness, this is a protractor. Okay. Um, this is what we will use to measure angles. Okay. We won't be actually using this to physically measure the angles today. We're just going to get used to how do we read this. Okay. The protractor postulate says given ray BA and a point C not on ray BA, a unique real number from 0 to 180 can be assigned to ray BC. So notice that I have ray BA and it's going through the 0 on the outside. And it comes all the way up here to ray BC. You always want to start on the 0. Okay? So depending on if you're starting on the left-hand side or the right-hand side, which angle you're looking at, okay, on where you would start. If I was reading this angle between the A and the C, I would read my outside numbers. If I was over here and I was looking at angle DBC from the D to the C, I would start on the inside because that's where my 0 is. So now let's talk about notation. If you have a lowercase m in front of an angle, it's asking you for the measure of that angle. Your answer will always be a number with a degree symbol, and you'll have an equal sign. So we're going to practice using the protractor postulate. So here they give me this picture, the protractor, and all of these different angles in the picture. And so first it says find, notice the lowercase m and then angle, so it's asking me to find the measure of angle BEC. So BEC, I just want in between here, okay? The first thing that I'm going to do, we're going to come down and look at number 2 first, because number 2 asks for the measure of angle AEC. So if I go AEC, that's from A to C. My 0 is on the outside. So I would read from the A, starting at 0, all the way to the C to the outside, and it's halfway between 100 and 110. So I would say the measure of angle AEC is equal to 105 degrees. So now if I know that this whole thing is 105, I can look at A to B. A to B looks to be about 47 degrees, because there's 45, and it looks maybe 2 past. And so this area, B to C, would be 105 minus 47. So I could say the measure of angle BEC is equal to 58 degrees. All right. The last one using this picture, the measure of angle BED. So BE to D. Again, if I started at A and I went all the way to D, I see that that is 130 degrees. I just want from B to D, so I would again take out the 47. So I would say 130 minus 47. And so the measure of angle BED is equal to 83 degrees. And so yesterday when we were dealing with segments, we had the segment addition postulate, which was SAP. So today we have the angle addition postulate. We abbreviate it with AAP. It's very, very similar. It says if point D is in the interior of angle ABC. So here's my angle ABC. And I have D somewhere in between there. So now I have actually created angle CBD and angle ABD. And so what's saying is that if I take this angle and this angle and I add them together, I get the entire angle back. Okay? Yesterday we talked about tick marks on segments. We have angle marks on angles. And so that's where I did like one little angle mark here, two angle marks there, and then I got this great big angle when I added them together. All right, so let's look at the next page. So example 2, we're going to use the angle addition postulate, and we're going to start off with a word problem. So in this picture, it tells me that a lighting designer is finalizing the lighting plan for an upcoming production. The spotlight, this is my spotlight right here, can rotate 25 degrees to the left or right from the shown position. The beam of light from the spotlight forms a 22-degree angle. So that's what they have shaded in here. This is 22 degrees. Can the designer use the spotlight to light every object that's on the stage? They tell me that the entire angle, all the way from the chair over to the table, is 74 degrees. They tell me from the chair to the rug is 57 degrees. So the very first thing that, excuse me, that I can do is find out how far is it from, or sorry, from the chair over here to the door. They tell me it was 57. So I can find this area in here from the chair to the rug. If I do 57 minus the 22, and that's going to get me 35 degrees. So I now know that this is 35 degrees in here. I know that the entire thing was 74. If I take this 57 and I subtract the 74 from it, that's going to tell me this little part in here. So now I'm going to do 74 minus 57, and I get 17 degrees. So this little in here is 17 degrees. I'm starting here, and it can rotate 25 degrees to the left or to the right. Okay? So from this section that's shaded, if I go 25 degrees over here, I'm good because this was only 17 degrees to my table. But if I rotate this direction, I can only go 25 degrees, but between the rug and the chair was 35 degrees. And so 35 is greater than 25. Therefore, my answer is no, the chair would not be included. So it would not be lit with the spotlight. Again, on this side, because 17 was less than 25, the table is included. So now number 2, we're going to use the same picture. Okay, so I'm just going to redraw that picture for us. I can. So I'm going to redraw this picture. Here's my table. Here's my chair. I have the rug and the door. Now they're telling me, I'm just going to switch colors so we can see a little bit better, that I can rotate 33 degrees. Okay, so now um, the spotlight uses a 33-degree beam angle that can rotate 25 degrees to the left and to the right. So that shaded section up there that was 22, that shaded section is now 33 degrees. Now would I be able to rotate and include everything? All the way across was still 74. So if I do, and from the chair to the door is still 57. So if I do 57 minus 33, because now my spotlight covers 33, that tells me that it's 24 degrees between the chair and the rug. This over here hasn't changed. It's still my 17 degrees. So now starting here, if I rotate this direction 25 degrees, 17 is still less than 25. So the table is in. If I'm starting here and I rotate this direction 25, my chair is only at 24. So 24 is less than 25. So this time my chair is in. And so here my answer is yes, everything gets lit with the spotlight. Yesterday we talked about segments and congruent segments. So today we're going to talk about congruent angles. So angles that have the same measure are congruent angles. The same number of arc marks or angle marks show congruent angles. So in here I have one little mark, and over here I have one little mark. That's telling me that they have the exact same measure. They're not telling me what measure that is, but I know that they are the same size. So I could say angle TUV is congruent to angle XYZ. I could also say that the measure of angle TUV is equal to the measure of angle XYZ. Remember that when I'm using an equal sign, I know a number for an answer. So if I write it this way with the M, I have to have an equal sign and a number. I'm telling you, I can tell you that angle degree, that measure. When I just use the congruent sign, I'm telling you, I can't tell you what the angle measure is, just that they are the exact same size. Okay? So again, notation is extremely important. So let's practice some examples. So we're using this picture over here. It says if angle XWZ, so XWZ, from X all the way over to Z, the entire angle is 127 degrees. They want, what is the measure of angle W, YWV? I'm just going to put an X in there. That's what I'm looking for, right there. Okay. I have this angle mark, one angle mark. I also have one angle mark over here. That tells me they're the same. So if this one is 32 degrees, this one is 32 degrees. The angle addition postulate tells me that if I add up all three of those angles, they have to equal the great big angle 127. So I can say 32 plus x plus 32 equals 127. And so here I have x plus 64 equals 127. Solve that, gets me x equals 63. I have to answer the question. So the measure of angle YWV is equal to 63 degrees. When I'm measuring an angle, that degree symbol, that is my units. Okay. Let's look at example 2. It says if angle NOP, so NOP, so trace it if that helps you. So I'm looking between N and P is 31. This is 31 degrees. Angle NOQ, NOQ is the entire angle is 114. They're asking what is angle ROQ? That's my X. Notice that this one and the one they're asking me to find have the same markings. So since I called this one X, I can call this one X. Again, the angle addition postulate tells me if I add those three angles up, I get this great big angle. So that's what I'm going to write. 31 plus X equals 114. So combine like terms, 31 plus 2x equals 114. Move my 31 over, so 2x equals 2x equals 83. Divide by 2, so x is equal to 41.5. Answer the question. The measure of angle ROQ is equal to 41.5 degrees. All right, we're going to add another problem. So example number 3. First, we want to talk about a vocab word, bisect. We'll talk about bisectors again in a couple days, but right now you just need to know that bisect means cuts in half. Okay? So anytime you see the word bisect, it's telling you that it cut it in half. So we're going to say that we have this angle, and we're going to call this angle ABC. And then we're going to come out and we're going to draw D. And so they're going to tell me that ray BD bisects angle ABC. With that information, I can put an angle mark, the exact same angle mark on both of those. So if I told you that the problem said that this part of the angle is labeled as 4x in between here, and in between here is labeled as 2x plus 10. And we want to find the measure of the entire angle. To find x, since this bisected it and those are the same, I simply set them equal to each other. So 4x equals 2x plus 10. Move this 2x over, so then I have 2x equals 10 and x equals 5. Now, it doesn't matter which one of these I plug my x into because they're both the same. So if I plug it into 4x, that's 4 times 5, that tells me that's 20 degrees. So I can now say the measure of angle ABD is 20 degrees. That's this top one. But I can also say the measure of angle, the bottom one, angle DBC, is also 20 degrees. So if I wanted the measure of the great big angle, angle ABC, the angle addition postulate tells me I add those two together and get 40 degrees. That wraps up the angle addition postulate.